Now let's look at the push flag, PSH. So one of the flags present is PSH. If you look at that fourth flag from the ending, that is PSH. In the fourth row, fourth flag from the ending is PSH flag, which is also called as push flag. Push flag. Okay. So the background of using this is like it. There is application layer, transport layer, network layer, and data link layer, physical layer. Application layer will give the data to transport layer, and it generally gives the data as a byte stream, which means transport layer will keep on getting byte by byte from the application layer. And what should this transport layer do is, it should prepare all the data bytes into one segment, and it should fill the segment so that it will reach the maximum segment size, and then put the header and then send it. By filling the entire segment so that it will reach the maximum segment size is one way to ensure that the data bytes are not wasted much, which means we don't want to waste lots of data bytes. Otherwise what happens is, if transport layer doesn't wait for more bytes to fill up the entire segment, what happens is, if you send for every byte if you send it down to the network layer, then for every 1 byte 20 bytes of transport layer header has to be added, and now for 1 byte 20 bytes of network layer header has to be added, and this has to be sent to the other side, and other side is going to pick up only 1 byte, and again other side is going to send pure acknowledgement. In case they are sending pure acknowledgement, then 20 bytes and then 20 and 20. So in order to send just 1 byte of useful data, we will end up nearly sending, I think how much, here there is 20, 81 bytes you are sending, which means if application layer is giving the transport layer only 1 byte at a time, and if transport layer sends 1 byte directly to the network layer, what happens is, for every 1 byte 20 bytes of transport layer header has to be added, and 20 bytes of network layer header has to be added, and we should get the acknowledgement for that. Therefore it is nearly 81 bytes will be transferred, out of which useful byte is only 1. Therefore efficiency is going to fall down rapidly, right? So in order to save us from this, transport layer will use the buffering technique. Buffering means it is not going to send the data immediately when it is given by the application layer. It is going to wait for some time and collect all the data so that it can form one big segment, that is called maximum segment, and then it is going to send one big segment all at once, right? So that is called as MSS, isn't it? So this is going to be the technique used at the transport layer, but then it is very efficient, but it is going to be a inefficiency for some of the applications. For example, if you are chatting, when you are sending some chat, let us say you have typed hi and typed the enter, then what happens is only 2 bytes have to be sent, which is hi. But then if transport layer waits for 1500 bytes so that it can make a one MSS, in case if MSS is 1500 bytes, then what happens is transport layer will collect the entire information 1500 bytes and then send your entire chat at once. It will not send hi, it will collect all your chat from one side and it will send everything at once. Then what happens? It will look like a email, it will not look like a chat. Therefore there are some applications which don't want this efficiency from transport layer. What they want is, whenever transport layer receives any data, even if it is 1 byte, it should push it immediately so that it can be sent to the destination. Even if it is 1 byte, even if it is a wastage, we need it. Such applications are called as interactive applications. Interactive applications. So interactive means like you're chatting. Internet chat is an interactive application. Even though you send only 1 byte, hi 2 bytes, those 2 bytes have to be sent to the other side. TCP should not hold it for a long time so that it will fill up the entire segment, right? So internet chat is such an application. And one more application is telnet, remote login. So what happens is those who are working with telnet or PuTTY or SSH or login, these are all the applications. So you might have seen at least one of them, and those who have already seen them, so those who didn't work on it, don't worry, you will work on it later in your masters. Those who are already working and those who have worked on these tools, you might have observed something. So whenever you open this telnet window and whenever you type something, it appears as if after you type something there is a delay after you type it and the character appears there. But then it doesn't mean that your computer is slow. If you open a notepad on the same computer and if you type something, that will appear fast. What I'm saying is, in your computer, if you are having this telnet window and if you type something like R, it will appear as if the word R is, the character R is typed or printed very slowly or very late after you type it, right? But if you open a notepad and if you type R, it will appear fast, which means as and when you type it, it will appear fast there. Then it doesn't mean that your computer is slow. What has really happened is, in a telnet screen, whenever you type something, it doesn't mean that from your keyboard directly the character is going to CPU and from CPU to the screen. Actually what is happening is, from keyboard the character will go to CPU, and from CPU the character has to go to the destination, some destination machine, and it has to be present there, and the destination has to send an acknowledgement, and then that will be printed here, which means whenever you see any character typed here, it means that that character is already sent to the destination. That is why generally in telnet or any SSH or PuTTY, whenever you are typing, you will not see anything there, and suddenly you will see that they have appeared there by magic. Suddenly all of a sudden they will appear 4 or 5 characters. What does that mean? You are sending all the characters one by one, and for all of them the acknowledgement has come at once. Then you are going to see them magically appearing there. So anyway, push is used to say TCP, not to buffer, push it. Therefore, application layer, whenever it gives any message, along with that it will say push equal to 1. This command it will send it to TCP. Whenever TCP gets push equal to 1, it will not buffer the message anymore, and even though the message is less than MSS, it is supposed to push it. And on the receiving side, and if the packet is sent to the receiver, and the receiving side, they also do the same thing. Receiver side will wait for many packets, combine them all together, and then send them at once to application layer. But then when you have push equal to 1 here, then receiver also should not buffer the data, it should immediately push to the upper layer. So push is used to push the data immediately downwards, as well as push is used to push the data immediately upwards at the sender and at the receiver. That is the main advantage of push flag. Okay.